You have learned the topic on forces before. Good. In school?
No, I have read up that. I've read up the chapter on a textbook.
Very good. Yeah, because you're very interested in science. Yeah, you said that, right? Okay, it's just a quick recap. Okay, what we covered. Yeah. You already know a force is either a push or a pull, right? And then it cannot be seen, but its effects can be felt. All right. Effects can be seen, but the force itself cannot. Okay. It can actually move a stationary object. So the ball initially not moving. If this boy kicks the ball will start moving. Okay. It can also stop a moving object. You can change the shape of an object, bend or even break it. You can change the direction of a moving object. Right, if let's say the object is moving, it can change its speed as well. Move faster or move slower, up to how a person manipulates. Okay, and then when an object does not move, okay, in this particular case, two boys pushing in different direction. Okay, opposite direction, in fact. So the forces acting on this particular box are balanced. All right. The energy is needed for force to be exerted. So all these are just facts. Okay, the concept that you need to know. Gravitational force, we also call it gravity. It's actually the pulling force exerted on objects by the earth. All of us are actually being pulled towards the center of the earth by gravity. This we all know. Okay, if you do not know, now you know. Gravity can even act from a distance. Okay, then for example, let's say we have moving objects, flying objects. They are also being pulled by gravity. Yeah, if you are not being pulled by gravity, what will happen? You will go into outer space, isn't it? Okay, then gravity prevents objects from floating into space. That's what I mean. So all these are examples. These are durians falling, okay, people bungee jumping, parachutists falling back to the earth. Okay, basketball also will fall back to the ground because of the action of gravity. Now you also need to know weight and mass. They are different. Weight is actually measured in newtons. Mass is measured in grams or kilograms. Mass is the amount of substance inside an object. Okay, but weight is a measure of gravitational force. Our weight is derived due to the gravity pull. So it actually is different, for example, on Earth as well as on the moon. Do you all know this? Your weight is actually different on Earth and on the moon. Gautam, do you know this? You know, very good, okay? So do you think your weight is higher on Earth or is it on the moon?
On the moon.
On the moon, do you think so? Your weight is greater?
I think on the Earth.
On the Earth, because on Earth, okay, example, I just say example. Let's say if you are 50 kg in mass, your weight will be 500 newtons. But on the moon, okay, the pull of gravity is weaker. So therefore, your weight will also be lower. Okay, so it's like divided by 6 times around there. Okay, some general knowledge. Okay, so come back to this. Right, so your mass will not change no matter where you are, but weight will change depending on where an object is. The further the object is from the center of the Earth, the weaker the gravitational force that acts on it. Yeah, so all these are facts that you should know. Magnets. You learn about magnets when you are in P3 or P4. Some schools teach it in P3, some schools teach it in P4. Okay, so just to add on, okay, certain knowledge, in P5 and P6, the kind of questions you see for magnets will be tougher. It's not just as simple as asking you, label the poles and then they don't ask you to write down characteristics of magnet, etc. Yeah, it's not as simple as that anymore. It's going to be tougher. Application question will come in. So you already know, I'm not going to go through every single one because you are already familiar with this. Okay. Okay. So do I need to go through point by point? No need, right? Are y'all familiar with magnet so far? Okay. This is just a very quick summary. Next one, frictional force. Okay, something new you will learn in P6. Now, friction is produced when two objects, the surfaces are actually rubbing against each other. That's the frictional force that's being produced, right? It cannot act from a distance. Okay, it must be in contact, right? So friction acts in the opposite direction of motion. Effects of friction, yeah, or shall I go back to this point? Friction acts in the opposite direction of motion. So if you're walking in this direction, friction acts in the opposite direction, always. Clear? Effects of friction. Okay, friction can cause a moving object to slow down or come to a stop eventually. Okay, and then friction produces heat. So when you rub your palms together, heat is being produced. So you always see the action when people are in cold countries, they'll always rub their hands, right? Because they need some heat to keep them warm. Okay, friction also causes wear and tear. So the soles of the shoe will be worn out after some time. Okay, because of friction between, look at the different soles. Okay, the friction between the sole as well as the ground cause it to wear out. Friction wastes energy. Okay, energy is needed to overcome friction in machinery, even in our daily chores. Yeah, then friction is something very useful because it allows us to grip onto objects. It allows us to walk. It allows us to stand. It allows everything to be in place instead of slipping and falling. Okay, so you see, drive or ride a vehicle without the vehicle skidding. If let's say there's water on the road surface, if the tires are good, okay, if the tires are not worn out, it is still very safe for the motorbike to move. But if let's say the tires are worn out, okay, it's very, very dangerous because the vehicle can skid and then this person can die if it's very high speed. Okay, walking without sleeping and then stop moving object. Okay, and then amount of friction between two surfaces depends on the roughness or the smoothness of the two surfaces. Remember I said about water on the road, right? And then the tire. Okay, so the rougher the two surfaces, the greater the friction between them. Imagine you put sandpaper. Two pieces of sandpaper, they are rough surfaces in contact. Is it easy to move for them? No, it's not easy because it's too rough. There's a lot of friction. You need to put in a lot of energy and force to get them to rub against each other. All right, not easy. Okay, but still can happen. Friction can be reduced by using lubricants, rollers, or even wheels. So all these are things that you should know by now. All right, and then you can apply your knowledge into the questions. Now, elastic spring force. Okay, elastic spring force, you actually can create it by compressing or extending a spring. Okay, so a compressed spring over here, this is how it looks like, will exert a push, okay, while extended spring exerts a pull. Okay, so this you have to know. The heavier the object, the greater the force exerted. The greater will be the compression or extension of the spring. Okay, there is one thing you also need to know. We cannot compress or extend a spring if it reaches its elastic limit. This keyword here, elastic limit. So once it goes beyond that, for example, extension, if I have a spring and then I hang a load on it, it will come to a point where it will go beyond its elastic limit. And then even after removing the load, the spring will not go back to its original position or length. You know that? Okay, that is the elastic limit being reached. Okay, elastic spring force cannot act from a distance. So roughly the whole chapter on forces is like this, okay? So next, what do we do? I'm going to show you another set of slides. Okay, this is actually from 88 tuition. 6. Okay, so we have done this. All right, this is just a quick video. You can find many videos online. This is just one of them.
In the first part, we saw that force is not just a human pushing or pulling an object. A force is a push or pull upon an object resulting from its interaction with another object. There are two things we will cover in this video: types of forces and the effects of forces. For simplicity, we can classify forces into two types: contact forces and non-contact forces. Contact forces are just what they sound like: forces that result from the interaction of two objects in contact with each other. Are there any contact forces you know of? Of course you know a few. What happens when you softly kick the ball which is lying on the ground? You applied a force on the ball and there was contact. Applied force is one of the contact forces. Next, there is a force of friction which brings the ball to a halt. As the ball is in contact with the ground, the frictional force is also a contact force. Don't you think there was some air resistance? Yes, air resistance too is a contact force. The normal force, which is applying force in the upward direction, is a contact force as well. These were some of the contact forces we know of, but these are not the only ones. Can you think of any non-contact force? What happens when the ball is in the air? It will fall down, right? What pulls the ball down? Yes, it's the gravitational pull which is trying to pull the ball towards the center of the earth. This pull happens even if the object is not in physical contact with the earth. The gravitational force is an example of a non-contact force. Other examples of non-contact forces are electrical and magnetic forces. Now, I want you to think about the next question I'm going to ask you. What all can a force do? What can be its effects? Let me give you an example. A force can set a stationary object in motion. That's one of the things force can do. Can you think of the other things it can do? Assume an object is moving at a uniform velocity of 2 meters per second. If it is pushed harder, its velocity will increase. So force can also change the velocity of an object. A force can also stop a moving object. Anything else you can think of? Yes, force can also change the direction of a moving object. If a ball is moving towards the north, a kick from the right can change its direction to northwest. Is there anything else you can think of force can do? Come on, I want you to think really hard. Don't think only in terms of motion. A force can also change the shape of an object. If we apply force from both sides to a spherical ball, its shape changes. The ball's position does not change, but its shape does. So these are some of the things that force can do. In the next video, we will play an interesting game to know if you've really understood how forces act on an object.
Okay, now we talk about gravity, okay? And gravity is something that is also talked about in your classes. All right, just let me show you. Okay, because my previous class, they also ask what happens when there's no gravity. Okay, so since this is also important in school, I'm going to share this video with you. Go on. Okay.
This is air traffic control. You're cleared for takeoff.